Yes. So like I was saying just now, Linux is the core requirements of the role of a DevOps engineer or a DevOps personnel because every infrastructure, most infrastructure you interact with will mostly be based on Linux, and you also need to understand virtualization. But before we go into that, let's go through some basic concepts we mentioned last week. First off, moving forward, concepts. So last week we talked about Ansible and Terraform. So last week I was talking about how Ansible is an orchestration tool. Basically, Ansible is a leading DevOps tool basically. So we have Ansible itself, and we have a way we implement or what we call the Ansible orchestration platform. We call it Ansible Automation Platform, AAP. Basically call it Ansible Towers. But that was not the focus of this lesson. I'm just trying to introduce everything there because when we go further, Ansible is a topic of its own. Terraform is a topic of its own. I mean, it's a lesson of its own. They are all lessons of their own standalone. Everything we're trying to do here is to solidify concepts so that when we start seeing them as we move forward, they are not so foreign to us. So that's the basis of what's currently going on here. So moving on, um, Ansible, this is like a development to scale automation productivity. So Terraform is for infrastructure as code. I gave an example last week that Terraform to manage DNS names or DNS routing, AWS routing. Terraform is cloud agnostic, which means that you can use it on different cloud platforms. You can use it on AWS, you can use it on Azure, you can use it on Hawaii Cloud, you can use it on GCP. It's platform agnostic, so yes, you can use it everywhere. So I put them together here not because they are similar or they are the same thing. I put them together because I just want to make it snappy, make the concept segment snappy. So Terraform is an infrastructure as code tool. I mean, declarative construction because you have to write whatever action performation or whatever action or whatever configuration you need to update or whatever services you need to build up or whatever API you want to interact with. Everything is defined within your code, infrastructure as code. Like I said last week, all our goal is to manage and use or manage and handle an immutable infrastructure. And for us to do that, we need to control our infrastructure at the most basic layer of abstraction. Again, at the most basic layer of abstraction, which means that we need to handle it at code level. So the code level abstraction is where we handle everything. So we have better control there. So that's where tools like Terraform comes in. So you can just see Terraform as like, okay, this is used for build, why Ansible for configuration. Let's say you want to install something, you want to update, you want to modify Ansible, you want to build up Terraform. That's just simple concepts. We are just going through it. So we have popular Terraform commands and Ansible. Basically, you've heard of Terraform, probably you must have heard of Terraform init, Terraform plan, apply, Terraform destroy. I mean, you've seen this kind of resource. And also, there's one thing about Terraform. So you say, how does Terraform interact with different platforms? You can use Terraform for activity or DNS management. You can also use that same Terraform to manage a virtual machine infrastructure. You can use it to manage CI/CD platforms. You can use it to manage different servers. So how does Terraform interact with those things? So Terraform interacts with APIs using what is popularly known as providers. I didn't state that out because this is not a Terraform lesson. So we use what called Terraform providers. So we see Terraform providers for Rhapsody or AWS. You see Terraform providers for F5 big API networks. So if you go to Terraform documentation, you will see a lot of providers. I mean, I'll drop some links after this lesson that we can just go over some documentation. Even if you don't understand the full concepts, or just go through it. It will get there later when you are going deeper into DevOps engineering. Then Ansible, you get Ansible in YAML files. And Terraform is mostly in .tf .tn. And Ansible is mostly in YAML files where you define your task, your roles, and what have you. So I don't want to dwell too much on this because they are just concepts. In our concept, going forward into our concept, we have Docker, Jenkins, and Git. So Like I said before, Docker is a container, the containerization platform. Containers build and run anywhere. Docker is not the only available option for our container runtime. We have other options like container D, like CRI.o, LFXZ, and the likes. But Docker is the most popular. And depending on platforms, anyways, I mean, if you're using Kubernetes, I would not advise you to use Docker as our CRI, the container runtime interface. I would advise you to use Container D, but that was a conversation for when we get to Kubernetes. Um, so Docker enhances scalability, consistency, and the likes. Then Jenkins is an open source. I mean, we know what Jenkins. Okay, Jenkins is an open source, it's a continuous integration server. So we use it for CI/CD processes. I mean, it's not just only CI/CD for software development processes. We also use it for running jobs that can be data jobs, jobs to copy ETL scripts, jobs to trigger different things. Jenkins is an automation platform. So do not look at it from the lens of only CI/CD. It's really more than CI/CD, what we do with Jenkins or what you can do with Jenkins. And we are using Jenkins as a case study here. Does not mean this is the only CI/CD tool available. We have what we call GitHub Actions, Bitbucket pipelines, and the likes, Azure pipelines, AWS code pipeline, I mean, and the likes. So we just use Jenkins because Jenkins is one of the most popular, and when you are coming up in DevOps or when I don't say that, it's always important for you to understand the most basic, which is Jenkins. From Jenkins, you can transition to advanced configuration using the bucket pipelines and the likes, where you get to control every action of your CI/CD process with lines of code. That's enterprise level, basically. We have what we call Git. So today, Git is what we use in version control and version control management, where we can have multiple people working on a particular project without crashing changes. So today, we would say, so take it like this, we've heard of Bitbucket, we've heard of GitHub, we've heard of GitLab, we've heard of AWS, sorry, Azure repos, where when you implement Azure DevOps, where the repos. So those guys are all running on Git engine. Let me just call it Git engine. They are all based on the principle of Git. Git is the underlying technology behind those source code management tools. Something like Bitbucket, GitHub, they are all SCMs, called on source code management. We use them to manage code for application logic. Today you have a probably code for, let's say your WhatsApp now is on the Git repo. And let's say the history that repo is a GitHub repo. So how you branch out, how to commit, it's all controlled by Git. But the source code management tool will pick it up. But how you interact with it is what Git comes up with. Funny thing, the person who invented Linux is the person that also invented Git. So that one is an outside conversation. So one thing about DevOps is standardization and collaboration and smoothing processes, breaking down organizational silos. So it is important that we control versions, control the source code and version control. So that is why we have Git basically. We don't want what's running on production. Anyone is able to update whatever is running on production today. That is not what we want to develop. So that is why we implement version control and ways by which you can audit and control changes or the way changes are released. Moving on. Virtualization. So, what do we mean by virtualization? So, you've heard of the word virtual. It seems like you're an abstraction of something that is real but is not physically present. That is the English. That is the English terminology I would give virtualization. Before virtualization, so before now, then people normally run applications on servers, basically, whereby your application will be running bare metal. Like your laptop today, your Windows laptop is a server, basically. If let's say like over 10 of us or about 10 of us or over like 5 of us are together on the same network, we can decide to link all our laptops together. Under the same subnet, we can link everything together and use each of our laptops as servers. Our laptops are servers. Now, our laptops have a base OS, which is the Windows operating system. For those using Mac OS, that's a different operating system. So Now, I can run another OS on top of my Windows operating system. I can run a Linux OS there, whereby I might have to partition based on location. So based on boot location, let me call it like that. So now the Linux machine running on my host on my guest on my base OS, which is my Windows OS, becomes a guest OS, the Linux machine running on it. So it seems that there's a machine running on my laptop. I mean, there is a machine running on my laptop, but that is not the base OS or the host OS on the laptop. So that is what we call virtualization. And something makes that possible. There's what we call hypervisors, which I will talk more on the next slide, in subsequent slides. So that's what virtualization is all about. But before that, let's look at what life was before virtualization. Before virtualization, each application or service requires its own dedicated physical server. Yes, this server A and so is used to run this particular application. It's used to run this one. Used to run, let's say, Google.com. The search engine is run on this set of servers then. So that can lead to several things. Number one, over provisioning. So you always, as a business person or someone who are working in business environment, you always be like, okay, so that we don't get overwhelmed, less over provision. And that will lead to higher infrastructure cost because it's very expensive to run data centers where these kind of physical servers run. Resources were often underutilized because servers are running at low capacity. You just have one application running on the particular virtual machine. So that means you are not making use of all the total compute, available compute and resources allocated to that particular virtual machine. Sorry, that particular server. Now, high cost, like I said before, servers are very expensive. Running data centers are expensive. That is the operational expenditure. The data center has 24/7 electricity. There is no 1 minute out. Then also talk about space. Data center space not using efficiently and complex management of physical infrastructure because you might get to have so many VMs even when you're not using several of them because you just don't want to be overwhelmed when the time comes. So that is for virtualization. Now, virtualization itself, instead of running that application on that perimeter server just once, I can decide to run different instances of a Linux machine on the particular host OS. It can be a Windows operating system or whatever operating system. I can decide to run, let's say, a CentOS and Ubuntu machine. They will all be assigned different IPs. So I can run different applications on these different operating systems on that particular physical server that would have just natively run only one application. So that is what virtualization is talking about. But let me just go about this slide. And if you have any question, drop it on chat. We'll attend to it. Now, virtualization is a technology that allows you to create a virtual simulated environment from a single physical machine. So just to put this in perspective, think of that one server that basic meta server that would run your application before. Now it can run multiple applications because you can set up different operating systems on that particular server. And like I said, the ability for you to set up different OSs on a particular host OS is made possible by a hypervisor. So further also, we'll talk about the disadvantages of virtualization or virtual machines and why containers are the best, no longer virtual machines. So, technology has evolved. So we need to follow the technological trends to have a solid foundation. So yeah, like administering the DevOps, basically, to be a good DevOps person. So through this process, IT professionals can make use of their previous investments and optimize the physical machine's full capacity by distributing resources that are traditionally bound to hardware across memory. So it's what I just said before. Now you have one physical server, probably buys 500 gig of RAM, 500 gig of storage, SSD, has 64 gig of RAM. The application I was doing on that bare metal server before doesn't require up to 20 gig in storage for SSD and doesn't require up to 4 gig in RAM. So that means you are wasting like hundreds of gigs of storage and tons of RAM. And we know that RAM and storage is the most expensive, whatever infrastructure you are trying to buy. If you want to buy a server, the higher the RAM and the specification of that server, the higher the RAM and the storage, the more expensive. You are buying a laptop today. Once your laptop costs from 512 gigabytes RAM, sorry, 512 gigabytes of storage, SSD, to 1 terabyte, you know that cost is doubling. If your RAM is between 16 and 32, it's not the same as 8 gig of RAM or 5 gig of RAM. So These are the most expensive. These are the things that determine cost. So now you have the ability to maximize that particular resource by hosting different OSs on that physical server. That is what virtualization is all about. So once more operating system can run on the single star machine, like I said before, I can decide to say, okay, let me set up a Linux box on this server. I can use that and say, okay, since I set up a Linux box, let me set up a Windows OS on top of that Linux box on that physical server. So I now have abstraction of operating systems depending on requirements or depending on what I have to achieve anyways. So multiple OS can run in a single server. CPU RAM storage opportunity virtual exactly. Data resource utilization and cost efficiency, improve isolation. So normally you will use five servers to run 5 applications. Now you can use one server to run 5 applications, depending on the application requirement anyways, compute requirements. So that is the idea behind virtualization. And more flexible deployment and management. So you don't get to manage so many servers. You get to manage fewer servers for more applications within them. And it becomes easier. So now virtualization was the technology after traditional virtual machines. Now, after virtualization, we have containerization. For containerization, we went into container orchestration. For container orchestration, we are now going into serverless compute, but again, that is the trend. So virtualization, more flexible deployment and management. So now we have key technologies we use in virtualization, host operating system. So today now I can use your laptop or my laptop as an example. My laptop is a Windows laptop. I have a Windows operating system, which is the one directly interacting with my hardware components. Now, I can try to install a guest OS as a guest operating system. Today, I have Ubuntu and WSL Ubuntu on top of my Windows laptop, which means I'm running Linux on top of my Windows OS. That means that my Linux is my guest OS, while my host OS is my Windows machine. I can decide to install VirtualBox and use Vagrant to install several virtual machines or use multipass. Like I've already used multipass. Currently I have different virtual machines or servers on my laptop by multipass. So as we go further on this course, I'll also share you a requirement whereby you will set up virtual machines on your laptops and you will run different operating systems on your laptop using Vagrant and VirtualBox, Oracle VirtualBox. So again, that will give you practical experience as to host OS, guest OS. Now, the guest OS is what? Like I said, the Linux run on top of my Windows operating system. So each guest OS thinks it has a dedicated hardware. You get so it's not like Ubuntu thinks he has everything to himself. CentOS on my same laptop thinks he has everything to himself, but all of them are run together, and I can do more. Now, the virtual machine is going to be a software-based computer because if you want to run a virtual machine on a laptop, you have to download the ISO image and start it up, and configure it and start it up. So that's the long way. We have easier ways to manage that. We also get to that because we also have to look at traditional virtual machine management, the difficulties in virtual machine management, and we'll talk about easier instances or easier ways to run and set up your virtual machines. Now, virtual machine contains its own CPU, memory, storage, and network interface. When you're running on your Windows laptop or your Mac OS laptop, it's technically assigned an IP. You can control the IP that should be assigned to it, but dynamically is assigned an IP. And it runs independently of other VMs. So you can decide to set up 5 instances of virtual machine on your laptop using Vagrant today. Vagrant, I will introduce to Vagrant subsequently. You can set up different virtual machines using Vagrant and they will run independently. You can SSH into them separately. That means you can go into either of them separately. Then snapshots. So today you can easily take a snapshot of a virtual machine. That means that it's just like a snapshot of your OS, a backup. So that once that virtual machine goes down or that server, the infrastructure supporting that virtual machine goes down, you can restore that virtual machine in a different host operating system. That's what the essence of snapshot is. For those that are going deeper into storage and compute. So we have DevOps engineers, we have network engineers, we have storage and compute engineers. So for those that are going deeper into storage and compute, they'll be doing a lot of snapshot. If you are good at, if you are used to AWS, you are used to managing EC2 instances, you would also understand the concept behind snapshots. Snapshot is the backup, a point in time backup of your virtual machine state, resources, and everything. Remember I mentioned hypervisor. So hypervisor is the software layer that manages VMs. So we have two types. We actually have pipeline. Remember, I went directly on the hardware. That's what we mostly use in data centers today. When you go to Revolution data centers, you go to MTN's data center, you go to Reuters data center, you go to Interseries data center, you see virtual machines running, noise everywhere. But those virtual machines are running on bare metal. So as I run on bare metals, we can have other machines running on top of them. Now, these type one hypervisors runs directly on the hardware. Now, type two runs on top of an operating system. So today, we have a Windows, I have a Windows laptop, we have a Windows laptop, and I install VirtualBox to manage virtual machines that I'm going to install using Vagrant or using another tool of choice, whether multipass or anything. VirtualBox becomes my what's it called, my hypervisor, because it's running on top of the Windows operating system. So in the requirements I'll give to you guys to the text documents, you will also find commands that you use to install VirtualBox, the hypervisor you will use on a laptop, and to play around with the Linux environment. So these are basic key technologies we use in virtualization. I fear that this time will not be enough for us. But again, let's see. We can always rejoin the lesson. VM architecture. So basically what I've explained today, you have VM now. Take this as just one Windows laptop. Just take this as one Windows laptop. You have the Windows hardware, which is basically your battery, your motherboard, and those are the hardware. Then the operating system installed on the hardware. If you have your hypervisor now, in this case, VirtualBox, which you will install subsequently. Then we have Brightflare. So I decided to install Ubuntu here. I decided to install Centauros here, and I decided to install Fedora here. I'm looking for different applications. Let's say I can run the front end here, run the back end here, run the database here. All within my Windows machine. Functionally, before now, we would have just run just one app here, just one app on the native virtual machine. So yeah. If you have any question, please drop in chat. So moving forward, so like I said, there are 6 challenges to virtual machines. Traditional VM, you have OS installation. So if you want to install a virtual machine traditionally, you have to go and download the ISO image, you have to download the image and install it, and it take a lot of time. And it's prone to manual and human error. You have to find a way to do this, do that. How do I multiply these, or how do I install another one after installing this basic component from 2.04? So it's somehow laborious. So again, DevOps is all about continuous improvement and getting better. So these challenges led to the development of several automation tools. Like I mentioned, Vagrant for development environments. Today we can use Vagrant to install several virtual machines at once. Or you use a Vagrant file, or you just go to the website vagrantscloud.com, copy the commands that they have there, listed out there, run it on your local Windows machine. So now you have Vagrant installed and you are good to go. Terraform for cloud infrastructure, like we mentioned, Terraform for Ansible for conversion management, and Docker for containerization, all because of these challenges. So containerization basically, makes it easier than is it easier? It's better than virtualization. Let me put it that way. But it depends on business requirement anyways. There are sometimes you will need to run the application on the virtual machine. The requirement to be virtual machine, especially when it is highly resource intensive or moving on. So containerization is majorly for a lot of microservices. VMs are still a thing. It's not like VMs are bad. They're still a thing. A lot of organizations today run their applications on virtual machines. A lot of banks, a lot of organizations run their applications on virtual machines. In the same vein, we have a lot of organizations who are basically on container infrastructure, containerization, Kubernetes, Docker, and the likes. So, which is bad, which is not bad. They are all useful depending on business criteria or business needs. Now, remember, Vagrant is an automation tool. So we are going forward to look into Vagrant because we are going to have to use Vagrant with the text sheet I'm going to share with you guys because we don't have sufficient time to do the setup on this call. You have to do it on your own. If you have any questions, you can always reach out. Brilliant. Eliminate manual OS installation. Exactly. All you need to do is install Chocolatey on your laptop, on your Windows laptop, then do Choco install Vagrant. After installing Vagrant, use Vagrant init Vagrant file. Your VM is starting up in the nearest minute. So we'll see this. Use to configure VM images or boxes. Like I said, when you go to vagrantcloud.com, you will see several images there that you could use, Ubuntu, CentOS, configuration as code using Vagrant file. So you can define whatever you want in your view and in your Vagrant file. All these are just stories. Once you follow the instructions I have on the text to install, when you interact with it, all this will make more sense. So that's a simple command line interface. I mean, Linux systems, Vagrant is also based on Linux. Let me just put that out. The VMs you are installing will be based on Linux. That is why it is imperative to look at Linux in this class. So yes. Consistent environment across team members, conversion as code, simple command line interface, exactly. So everything is just Vagrant in Unity. When you initialize your VM boards, you do Vagrant up to start up your VM. Vagrant SSH, you know, of the virtual machine, and you are good to go. The key Vagrant components, you have Vagrant boxes, the VM, whatever. Like I said, it's available on Vagrant Cloud, publicly options, different OS and conversion, like I've mentioned. All the that everything is just there. You can create custom boxes. You can decide to take a Vagrant file, modify it according to your own requirements, and get it done. Configuration file is a Ruby syntax. I mean, you don't have to go and learn Ruby programming language. It's just the basics. Once you look at the file, you see how the language is structured, how the variables are declared, and wherever you are going to go. You don't need to go and learn Ruby for this. So you don't waste productive time I could use to achieve the maximum and use it for something else. So that said, using productive time that you have used for something else, I hope you know what is called the Pareto principle. That's just on the side anyways. I mean, it's all part of the DevOps culture, agile DevOps. We'll get there. I mean, we'll get there. Or I would like us to go way more technical. So this is also just an introduction aspect. After this introduction, and I share the requirements, I expect every installation to happen before my next session with you. So yeah. Vagrant defines VM settings, the big box, whether you're using Ubuntu, whether you're using Fedora, whether you're using SUSE, whatever, network operation, shared folders, resource allocation, you can specify everything here inside the Vagrant file. Everything here can be specified inside the Vagrant file. Moving on. So the last command, I mean, like I said, I just took a snapshot from my VS Code and dropped it here. I mean, just go to vagrantcloud.com. You get this particular link will lead you to this box. You can go back, you can copy this link from here. And still on Discover, you see several boxes there. So you can stop here. I use zero Linux Vagrant. You will see several boxes there. So Vagrant init, box name, CentOS streamline, Vagrant all, Vagrant SSH, Vagrant what is to stop, and Vagrant destroys the virtual machine. So these are just basic commands these are basic commands anyway. These are just basic commands that you use to manage Vagrant instead of looking for where to, first of all, downloading the Ubuntu image and initializing it with Vagrant. You automate everything. You just have to run a couple of commands. So when you have Vagrant installed on your local machine. Now, from there, we go into Linux. I mean, this session is not going to be enough. I mean, DevOps is a should I say, a very broad aspect. If you remember really well, when I mentioned in the first class that one of the key difficulties in DevOps is the tooling, because we deal with a lot of tools, and that means you have to deal with a lot of technologies, and we have to have a lot of knowledge. So we need to delve a lot. So you mostly get the best output from personal work and personal investigation. We'll be there for guidance and training and assistance in terms of the course, but the best is after I've told you about Vagrant, I've sent you the requirement how to install the commands or how to install all the tools you need to set up ahead of practicalizing DevOps. If you can go, you can take the step further and say, can I do more with Vagrant other than what I've been told? That is where the whole difference comes in. And also, if this meeting ends abruptly, we can join again at the link. So, so if this week is if the meeting ends abruptly, we can always join on the link. So now we'll be talking about Linux. So we talked about virtual machines, servers. Like I mentioned, over 90% of the servers worldwide are based on Linux. Today, there are more Linux OS than any other operating system in the world. So Linux is a big thing, it's a big deal. So well, it's still remains an OS, basically. So Linux is an operating system, much like our Microsoft Windows or Apple Mac. And like other mention of this system, Linux is made freely. So we know that Linux is open source, which means it's open for all. The source code is available for all, and people can modify, unlike Apple Mac OS operating system, the Macintosh OS, which is not open source. So Linux was invented, or I mean, Linux servers. I mean, Linux is based on the Unix OS. Linux servers made demonstration or made some modifications and builds and improvements on that. And in October 1991, he made his first version of Linux, version 0.02. So at that point, Linux was able to run Bash. So we not call it Bash, but it's an abbreviation of something which is called Born Again Shell. That's why I highlighted it here in chapter, what's it called, bold, Born Again Shell, and GCC, the GNU C compiler. So it's all about Unix, and these are all stories anyways, but it's just necessary to have that background as we are going deeper into Linux, because you'll be interacting more and more and more with Linux as you go deeper into the DevOps journey. So today, Linux has found